We're going to talk about quadratic inequalities. Okay, so first, let's look at what they are. So far, we have been learning equations like this. X squared minus 4x minus 12 equals 0. This is a quadratic equation. It's quadratic because the highest power term is 2. It's an equation because we got the equal sign. Alright, so let's look at, for example, this. X squared minus 4x minus 12 is greater than 0. Now, this is a quadratic inequality. Okay, same reason for quadratic. It's now an inequality because we no longer have the equal sign. We have greater than. It should be quite obvious that there are 4 possibilities of inequality. Smaller than, greater than, smaller than or equal to, and greater than or equal to. Okay, we are going to learn by example. Okay, so let's dive into it. Find a set of values of x for which x squared minus 4x minus 12 is greater than 0. So the key here to solving this question is we want to first turn it into an equation first. So let's assume that it's an equal sign here. We want to do this so that we can find the critical points. Now, how do we go about solving this? There are various ways. Here, we will just do factorization. So it's x minus 6 times x plus 2 equals 0. Therefore, x is 6 or x is negative 2. Okay, and then let's go back to the inequality. Please do not just assume the solution is between those two values. Okay, it's really easy to make a mistake. We need to properly examine it. So now, let's look at the equation here. Well, it's the coefficient here, a, for the x squared term, is 1. It's positive, so that means the shape of it is this. It opens upward. So now, let's draw a quick sketch for this quadratic graph. Okay, we'll have negative 2 here and 6 here. All right, the graph opens upward. So we want to have something like this. And now let's go back to our inequality here. We want this to be greater than 0. Greater than 0 means above the x-axis. So it's actually this part of the curve and this part of the curve. So our solutions are actually x should be less than negative 2 or x is greater than 6. Okay, you can see it's not between those two values. Okay, that's actually smaller than 0 rather than greater than 0. Okay, let's look at another example. Find the set of values for which 6 over x is greater than 2. Okay, x is obviously not 0. Now, it might be quite natural to just multiply both sides of the equation by x, and then you get 6 is greater than 2x. But you see, we know that x is not 0. But we don't know whether x is positive or negative. Well, if x were positive, then you multiply both sides by a positive number, that's fine. You don't need to switch the sign. But if x were negative, then you see if you multiply both sides by a negative number, you need to switch the sign. So this obviously can't work, okay? We can't do this. Instead, we should multiply both sides of the equation by x squared, because x squared is always positive. Given that x can't be 0, it's always positive. So if you multiply both sides of the equation by a positive number, that's fine. You don't need to switch the sign. All right, so we get 6x is greater than 2x squared. So we have 2x squared minus 6x is smaller than 0. Let's go ahead and apply that key step of changing it into an equation first. Okay, so equal to 0. We'll take 2x out. So we have 2x times x minus 3 equals 0. Therefore, x is 0 or x is 3. Again, we want to do a quick sketch, okay, to properly examine it. All right, so let's go ahead and do that. So you see, the equation has got the coefficient here being positive. So that means the shape is this. Let's draw a sketch. 0 and 3. We want it to open upward. It looks like this. Now let's go back to our inequality here. We want it to be less than 0. So that means we want this part of the solution. So therefore, our inequality should be x needs to be greater than 0 and smaller than 3. Okay, as usual, I will assign homework here. Please try these questions and we will go over homework in our next video.